Number 12, professional application. One hazard of space travel is debris left by previous missions. There are several thousand objects orbiting Earth that are large enough to be detected by radar, but there are far greater numbers of very small objects, such as flakes of paint. Calculate the force exerted by a 0.1 milligram chip of paint that strikes a spacecraft window at a relative speed of 4 times 10 to the 3 meters per second, given the collision lasts 6 times 10 to the minus 8 seconds. All right. So here's our chip of paint, and it is about half the size of the spacecraft, so that's I guess a pretty large chip of paint, and it is traveling in this direction. It has a certain velocity. We'll call this the initial velocity. And there's one assumption that has to be made here. When the paint hits the spacecraft, its velocity will be 0 at the end. Okay, so the final velocity here of the paint chip will be 0. So now what we need to do is we need to somehow figure out how do we calculate force given the change in velocity and the time of the collision. Well, realize that this object has some momentum, right? It has a mass and it has some initial velocity, and then it's going to change its velocity and go to 0. So it has some change in momentum, right? Because remember, momentum is equal to mv. So knowing that there's a change in momentum and there's a time over which this force is applied to the paint, we can then finally calculate the force by using the first equation over here, right? So it says that the change in momentum is equal to the force applied multiplied by the change in time. So to find force, just simply divide out the time from both sides. So now this tells us that the force is going to be equal to the change in momentum divided by the time. Okay, let's expand the change in momentum. Remember, change in momentum will be the final momentum, which is mvf minus mvi. Now I can combine those terms because they have a common m, right? So it could just be final velocity minus the initial velocity. Okay, all divided by then the time. And then this is going to be F, right, is equal to the force. So remember, this is the force applied in order to change the momentum of the object. So if you think about it, if this paint chip over here is coming in with this direction of speed and it's traveling at 4 times 10 to the 3 meters per second, and then it's eventually going to come to a halt here, what direction does the force have to face in order to stop that motion? It has to face this way, right? So we should expect to get a negative answer here. All right, so let's just make sure that works out. So what's the mass of the paint chip? Well, it tells us it's 0.1 milligrams, but remember we need it in kilograms. So we have to take 0.1 milligram, multiply it. You can go to gram and then convert it into kilogram from here, or you can just place in the numbers, well, the values first, milligram down there, kilogram on the top. Essentially it's 10 to the minus 3 and then 10 to the third. Okay, and we realize that we have a value of 10 to the 6. So this would be 0.1 times 10 to the 6 without using the calculator, right? And then you can move that decimal one place on over to the right if you liked. So it'd be 1 times 10 to the minus 7. Okay, so that's the mass. So let's plug that in. So it's 1. Actually, let me just box this formula for you guys. It's a useful formula to know. So 1 times 10 to the minus 7 multiplied by the final velocity, we said it was 0. The initial velocity, it was pointing to the right-hand side. Therefore, it's positive. And it has a value of 4.00 times 10 to the third. Okay, all divided by the time over which this force acted, and it told us that the collision lasts for 6 times 10 to the minus 8 seconds, and this would give us our force. So we just got to simply plug it in. Let's see what we get. So 1 times 10 to the minus 7 times negative, essentially, right? 4 times 10 to the third divided by 6 times 10 to the minus 8. Look at that, negative. There it is. So we get the force is equal to negative 6.67 times 10 to the third. Okay, times 10 to the third, and that's in terms of newtons. All right. Now, we could probably just give the positive answer, right? If I pretend I had just said the paint chip starts here and it goes this way, now all of a sudden my initial velocity is in the negative direction, so there's a double negative in the in the formula here, and all of a sudden this is positive. Now the force is positive. So it totally depends on the way I frame the problem. So don't worry about what sign it should be. Just worry about the magnitude here. All right, so the answer should be 6.67 times 10 to the 3 newtons. And remember, the sign just tells us the direction, but the direction is totally dependent upon what I choose here because they didn't give me any further guidance on that. So guys, thanks so very much for tuning in. I really do hope this helped. Please remember to subscribe, and I look forward to helping you with the next question. Have a great day.